accelerating it.
Alrighty, I'm between us and a show floor and snacks and Lance looking at me with very devious eyes. Now, if I had known folks were giving awards, I would have actually brought in a pink hat to give Lance a pink hat award. But with that, I'd like to introduce Riccardo Badalone. Does that sound good? I'm actually part Italian, but it's only the hands that are Italian. He's one of the co-founders of Diablo and has served as a director of the company since its inception in 2003. He has been the CEO since 2007. And I went through the rest of his bio and it said smart thing, smart thing, smart thing. So we have an incredibly smart person here, a ton of history. And it's going to be a great opportunity for all of us to learn a lot in the market. So with that, and the fact that Lance is going to say, go, 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 I'd like to introduce Riccardo to the stage. So let's go ahead and give him a nice warm welcome.
Okay, I have to live up to being smart. I didn't appreciate that. Okay, so thanks everybody. I realize that it's towards the end of the day. I certainly save the best for last, so it's okay. So the theme for the discussion today is converge, as in things are starting to converge. And the idea is that this is the Open Server Summit. We have a keynote at the Flash Memory Summit, and there was a focus on flash memory. We'll be talking a little bit about that today and how we're looking to integrate that into servers. But the general theme is that things are changing in the industry in terms of how servers and compute are deployed. And there's a definite trend, and we're trying to accelerate that trend as a company. But I also think that the value is shifting from different areas of a silo type infrastructure arrangement to starting to really land in one place. And we feel pretty strongly, and I feel pretty strongly as a technologist, as a CEO, that it's starting to land in the server. So for those of us that are focused on server-side technology, hopefully this is relevant and hopefully it resonates with everybody. So, we usually have a bit of a gimmick theme at the beginning of every keynote. And this is a bit of a gimmick, but the idea here is to drive home a point. We look up there and we see a gaming utility, we see the Walkman, the computer for email, things, GPS, and a telephone. And I think everybody remembers it. I'm not old enough to remember the computer that's on the left. Maybe some of you guys are. I'm okay with that. I think some of you people know exactly, even what brand that was. But the idea is that it's kind of cool that it's all here. Right? I just want to let it sink in for 1 second. Everything that was there, and state-of-the-art at the time, and really cool and unique and new. Portability, entertainment, communication, navigation, and obviously compute resources now all here. And clearly, things that are in here are infinitely more powerful than they were when they were siloed and separate when they were first introduced. So if we look at the architectures that people are used to, you've got the servers on one side that really were compute nodes. They were expected to be stateless. It was a very important definition for something. There was nothing persistent about them except usually a little hard drive that was there to boot it up, load the operating system. Okay, so when it blew up, nothing was going to go with it that mattered. Okay? Everything that mattered to everybody in terms of your data, in terms of your bank account, whatever it is, anything that you would expect that you would never lose, that needs to be in a vault, was all the way on the right. And most importantly, for those of us that are trying to make a business, right? Trying to start, sell something, dealing with the enterprise or the cloud. And I admit that the cloud for me is not, the space that I'm the strongest in, but certainly the enterprise, I think I understand it quite well. And you had the concept of, well, I'm a storage guy, and I'm a server guy. And the storage guys were very, very strong bigots with regards to the server guys, and vice versa was the same. And that world is the world we lived in for the last, I think, probably 20, 30 years. What's happening today, I think to the benefit of everybody in the room, which I believe is a very strong trend, is that the intelligence, the value, is now converging in the server through what we call converged infrastructure. And what that means is that the server is now holding an element of persistence. It has either a disk or a flash element that is being used in conjunction with very intelligent software to store your data. And it's not just being stored there, it's usually going to be stored somewhere else in that rack or in another rack. And so when that server goes away, what's software defined about it is that some other piece of software running on some other server knows where the replica or knows how to recover that data. So there's tons and tons of investment going into the software and the hardware that allow that type of convergence to take place. And what's most important about that is now the scalability. You need more compute, you need more storage, you add more of these servers that are now armed with compute, memory, and most importantly, persistence. Okay? Now, in terms of where we fit in a major trend, I mean, obviously flash is becoming a very important part of what we call, converged memory. Right? And what Diablo coins converged memory is very simply, well, we have DRAM and we have future memory. Right? And there are very amazing companies that are working on new types of memory technology that try to be as fast as RAM, try to be persistent, really dense, and obviously cost effective. But what we're looking for is we're looking for density, we're looking for byte addressability, in nanoseconds. Right? We want it to respond as fast as RAM. We want it to be persistent, very cost effective and scalable. Right? And so what we're building in Diablo, we're driving towards what we call converged memory, which we see as essentially a platform to start the change and a revolution to get purely converged, right? Where DRAM and flash are essentially working together. So if we look at the benefits of DRAM and flash separately on their own, there's things we really like and things we really don't like about each of them, right? And so what we try to do with this concept of converged memory is we try to take the best of each, combine them, and what that means to the user is that you've got performance, capacity, cost, density, and obviously the persistence, which is extremely important. So now when you look at your compute server, what you have is DRAM and flash working together to create a very high performance, persistent flash subsystem. And the key to making that happen is memory channel storage, right? And we've been developing and releasing concepts one bit at a time that are essentially driving towards what we call essentially converged memory, where the processing power of the CPU that's driven by the application sees nothing but a pool of what looks like RAM, but it's persistent, it's dense, it's big, it performs and behaves like DRAM, but it has all the properties of flash combined with the volatile memory that's DRAM. So what happens now? Okay, well, if we manage to build that, just trying to look a little bit more into the future, we manage to build that, think of the server now as a compute node. Think of it as something that can do work for you, right? And lots of companies are driving towards lower power cores, lots of threads, lots of CPU. They can do work. Right, and the work per watt per dollar is going down substantially. Right? And I think it's obvious that there are several processor vendors in the market, not just Intel, that are driving towards these types of architecture, which is the same fundamental compute node that is in this cell phone. Okay, and it's dense and it's powerful and it can do a lot of work for you, and clearly very cost effective. You combine it with intelligent interconnect, and intelligent interconnect isn't just the NIC. It's the software that is running either in the NIC, alongside the NIC, or on top of the NIC that can understand, hey, this iSCSI packet is going here. This piece of information needs to be terminated there, and I don't need to tell the kernel. right? What happens is the more intelligent the interconnect gets, the less the operating system needs to get involved, right? And what happens is that starts to drive efficiencies around CPU utilization and, most importantly, responsiveness of the network. Latency is something that when we're building in large clusters, it's very difficult to deal with. So if you're trying to replicate data or fetch data across multiple units of compute that are network attached, dealing with the latency and response time of that system is extremely important to model. So the more intelligent the interconnect fabric can be, the more it can offload from the CPU and the operating system. Right? And so more and more we're investing in efficient and intelligent interconnect. And obviously you want to combine that with a pool of, let's just call it converged memory, right? You can use it as storage, you can use it as scratch pad, you can use it to keep your metadata, your application data. But the reality is you carve it out the way you need it, and each of these servers is essentially performing dual functions. It's persisting your data, and it's also providing now compute performance and power, which is making you money, driving your business, making your employees efficient and productive. What happens is when you scale it up, and so translate that picture into the rack, right? You want to be able to ingest data from everywhere. And this is all about data is constantly being generated by everything we do. You want to be able to ingest it from just about anywhere in that fabric. And you want to be able to move it around to any of the compute nodes or move the work to where the data is locally. And so data is residing within every one of those compute nodes. Work is done, and then it can be either sent out of the fabric or ingested into the fabric. You can create and destroy objects at will because your memory is persistent if you need it to, or you can just erase things, right? You treat it like RAM. Discard it or keep it. It's up to you. And real-time analysis and computation becomes extremely possible now. And we talked a lot at Flash Memory Summit about, okay, well, what can we do with very dense, very scalable, real-time in-memory compute? And I think the possibilities are endless, right? The more we can respond immediately to reactions, clearly it has very, very neat large implications in terms of the use cases for scalable computing. And I think the ability to scale to the demands of any data set and any problem are exactly what is driving the growth of real-time analytics today. And it's something that you touch every day in your life, right down to what we're going to talk about today, medical. So I'm Canadian, and I'm not sure that everything that I'm going to talk about today applies to me. So when I learned about this use case, one of our customers that we're working to help succeed, that's looking at software-defined storage and going towards all flash. Their deployment is very dense, all flash, scale up, and they want to deploy that across lots and lots of hubs. And I asked the question, I said, well, I love the fact that we have a customer, I love the fact that they're really excited about what we're doing, but I don't get it. Why does a company that is dealing with IT infrastructure as a business, why are they so focused on performance? Like, they're literally dumping the classic network-attached storage, client-server, server-side caching architecture to blades, all-flash, distributed storage. Amazing transition. Why is that? Well, I didn't understand the level of automation that the medical industry is driving towards. And in Canada, it's not really a business. Medical care is state-run, and it's not a business. It's a service that's provided to people who pay taxes. But in a business, what you want is you want computers to do more and more work. You want to be more consistent about the care that you're providing, not just to make the customer happy, but to be able to actually drive down your cost. And it's starting to compute in my mind that as the computers start to tell the person, listen, we'll give this person this pill at this time, and log it, did you do it yet? The computers are starting to tell our healthcare people, your healthcare people, what to do and when. And so that kind of means that they can have a lower cost layer of people doing these activities. And they can add more and more value into their infrastructure. And they can simultaneously ingest more data, real time, react to what's happening real time, make sure that they're following protocol. And all they need to do is make sure that the person who's executing what the computers are saying are going to do it when they're told and they're trained properly. So now they're starting to run it like a business, and they're not running it necessarily purely like a service to someone who's paying taxes. And that's when I started to understand that in the end, right, what's happening is they can save hundreds of thousands of dollars in CapEx. So you say, well, who cares? Right, it's only $300,000, and I agree. But what they did was the customers said, okay, well, what you don't understand is that I can operate my business and save millions of dollars now because I'm changing the way I'm actually providing the service. I'm changing the cost structure, I'm changing who is providing the service and when, and I'm able to translate every time the doctor or someone else does something, I can actually put it in, deal with the insurance companies, make sure that I get paid on time, make sure that I don't give the wrong pills at the wrong time, make sure I know how many pills I'm giving. And most importantly, I can save on human resource costs. So they can provide, ironically, a better service at a much lower cost. And in the end, that is what actually drove the decision for better IT. And so, you know, as a Canadian, I didn't appreciate it, but in the US, it's clearly a business, and they need to be competitive, and this is how they stay competitive. Give a better product, give a better service, and have it cost you less. That's the American way, right? And that's why it works. And so clearly this is being enabled by what we call hyper-converged infrastructure. So no more storage, no more servers, it's all in the server. And that should be important to everybody in this room that's driving towards business in the server. So, you know, we show a picture of a happy doctor, right? But in the end, it's his boss who's happy. And it's his boss who makes the decisions to buy our stuff, right? And that's where we can make a difference. So, I thought it was important to address the people that are going to try to resist this. No? Got to think about that a little bit. Things are changing. And we are literally taking what was in that storage closet and we're distributing it and shoving it into the services, right? Whether anybody likes it or not. And it's going to be faster, it's going to be better, it's going to be more scalable, and it's where the value is going to be, right? So my encouragement to people is to keep an open mind, right? You can build a very high availability, very high performance kind of storage infrastructure into your servers. And if you're a storage person, I encourage you to open up your mind and think a little bit about some of the trends and embrace them. If you're a server person, think about bringing in new technology that allows convergence. Initially, it is processors, RAM, flash storage. Soon that will be changing, right? The memory subsystem is going to change. It will be persistent. If it's not from something like MCS, it will be from new memory technologies that people are introducing, but clearly we're looking to make it MCS. But in the end, don't be left kind of standing with all the water coming in around. That's the message. Thank you very much. So I think there's a Q&A period. I'm not sure if there's any questions.
What are the properties of converged memory? One of the sections I heard that it has multi-core growth. Again, pressure on DRAM. Do you think that the converged memory can address that?
Absolutely.
And so, and the second question I had is, I took a slight, not a big, exception to the fact that intelligence and can definitely delete.
Absolutely.
And if
And
you're an inter-network, you would not want that.
true, so that's fair. And I made sure that the picture we showed of the rack had a switch in it somewhere. It's true, it does. It's at the top, okay? No, for sure, the network is important. You know, and clearly we're focused on the persistence piece, but what I was trying to say is that when you connect to the server, I mean, obviously the things that you're trying to get to within the network are in the server, right? And when you get into the server, for those of us who know how networking works, everybody thinks, yeah, I'm gonna go up into the operating system, I'm gonna go into the kernel, and then it's gonna basically figure out what I'm asking for. And what I'm saying is that Intelligent Interconnect doesn't do that. I believe that in the next 6 months, we will have technology that a virtual machine and a guest will be able to access a flash network element in a network-attached iSCSI environment, and it will never touch the hypervisor. Never. All right, so think about that. If it's a guest running in a virtualized environment, it's going to be just a regular Windows guest running on ESX in a cluster. Each cluster has got processors, memory, and flash. The flash is being used as storage. We can already imagine today how exactly to make that guest hit any flash in the network, and it never, ever goes through the kernel. Now that's very powerful, and I think that's exactly what I mean by intelligent interconnect, right? So clearly the switch, right? Some of the intelligence can be taken out of the switch and put into the NIC, and then you can start taking advantage of it. So that's what I meant, with all due respect, genuinely, okay? The second piece was, how does converged memory actually solve the problem? Well, it has to do with memory expansion. And all memory expansion does is, well, the processor has a certain amount of memory that it has available to it. If the data that it needs isn't in the memory, it typically has to, you know, it'll fault and page it in. Well, what we want to do is very simple. The data always has to be in the memory. Now, that doesn't mean that the application is running out of the flash. It just means that the data that the application that's running on that thread, the one that it wants, is going to be available when it needs it. The more threads you have, the more data sets you're operating in parallel. Depending on what application you're running, you can either run an application that spreads out over multiple threads and those work concurrently, or threads are doing different work. No matter how you cut it, flash is extremely important to increasing data locality to those threads that are doing work. And obviously in a fabric, you want to move the work to where the data is. And I think people are getting smart about that. You want to move the work to where the data is. You don't want to move the data to where the work can be done. And when you have a low latency fabric, when you have essentially let's call it a homogeneous pool of processors that are interconnected and they're all kind of working in tandem, ultimately you can move the work very easily, get it done, and then send the response outbound to anywhere in the fabric. Right? And when I say we can ingest, we can also throw out data anywhere in the fabric, and that's the idea. Make sense?
Thanks.
How do you envision dealing with memory as storage when you have a failure of a node and all of a sudden you have storage which is no longer available?
Yeah, so the key is you're typically, most of the time, if you don't want to lose that data, you need to put it at least in 2 places.
So how did you not just destroy your advantage of memory as storage?
Say that again?
If you have to put it in another place that's now remote, how did you not just destroy your advantage of memory as storage?
Most of the time, when we're talking about memory expansion, the data set is typically volatile. So the gentleman asked, hey, how do I feed more cores that are processing? That data, we typically want to treat it as volatile data. So you're taking advantage, from a memory expansion perspective, of locality on a more dense, cheaper medium. When you start getting into pure converged memory, what happens is you have to be able to replicate certain aspects of the data in two different places very quickly. And that's where the interconnect comes into play. So the more you can reduce the latency, the response time, and how many layers of software get involved when a 4K page shows up in this server and another server, that's how you basically can drive faster compute. So you cannot do replicated storage with high availability without having at least recoverable methods of the data in two places.
Right.
So that's how you do it. You gotta work on the interconnect.
So you actually envision there being an interconnect from memory to memory that doesn't
Absolutely.
involve the hubs?
Absolutely. That's why I talk about intelligent interconnect. There's no reason to get the operating system specifically involved when data replication is happening. No reason at all. So intelligent interconnect will allow you to move whatever data you deem has to be persistent. You can move it to known places without the kernel getting involved. And that's basically how it would work. You have to get the interconnect involved to drive the performance for the pure converged memory in a high availability environment. The interconnect has to be involved.
And what, from my point of view here, this may be fabulous, or this may fall on its face. It may just be so complex, because now you're talking interconnect from every possible component. So, is this,
We just talked
are you
about-
sure this is viable?
Well, we'll find out.
Never mind. Go ahead.
Let's give Riccardo a nice round of